So as we move on in lesson 6.1, or really start where the book starts, we're going to start dealing with integer exponents. So when we talk about integer exponents, we already know how to work with counting number ones. We already know how to do that. We know how to take something to the second power, to the 10th power. We know what to do with all of those. We know that 3 to the third power means what?
3 times
3 times 3 times 3, and so we know how to multiply like that. We know what to do there. But what if I say to you, now I want you to take 3 to the negative 3 power?
Becomes a negative decimal.
So 3
3
times
3 times.
3.
Actually, I do not know.
It would become a decimal because you go back 3 spaces on the. So if you had, say, you had 3 as just a whole number, and you had 3 to the negative third power, you go back, you move your decimal point up 3 spaces, so it'd be 0.03, right?
would that be moving in 3 places? If you, it sounds to me like you're moving it back, and if you have
1, 2, 3, so you'd have 0.
This is what he's trying to tell me, I think, you guys. I want you to be with me to see if I'm understanding it. You're saying moving it back? So right now it's right here behind it, right? So we're going to move it back. If it's to a negative 3 power, that means we're going to take it back
3 spaces.
3 spaces. And we wouldn't get 0.03, we'd get 0.003. Would that maybe be what it is? Is that what negative 3 power means? What did we do when we moved the decimal point back 3 places? What is that really, what are we really doing when we do that?
We're taking it times negative.
If you multiply by a negative,
100. Negative 100. We're taking it times by.
we're taking 3 times a negative 100. Oh, what is 3 times 100?
300.
300. What's a positive times a negative?
Negative.
That's negative 300.
We're dividing.
Oh, no, we're dividing. Okay, so now we're going to divide by 100. This is dividing by a negative 100? Is that what you said?
I just said divided by.
Oh, now it's, the negative is not part of it anymore. Now we're just dividing by 100. Okay, so 3 divided by 100. That would look like this. 3 divided by 100. Or in other words, 3 hundredths. Is this 3 hundredths?
No, it's 3,000.
This is 3 thousandths, right? So this is really this. So taking 3 to a negative 3 power would be the same as dividing by 1,000. That's what you think it might possibly be. Okay? Well, I'm going to say, no, it's not. Okay, so let's think about what, you know, before I even go to that, before we even go to that, have I handed those out yet? I have, right? Okay. Before we go to that, let's do some exploring of that 3 thing, okay? 3 to the positive 3 power means 3 times 3 times 3. 3 to the second power means 3 times 3. 3 to the first power, even though we don't typically write it, right? It's there, but we don't. What's that mean? 3. Well, this is what? 27. This is 9. This is just 3. Okay. What happened? When we went back 1 integer value, when we decreased it by 1, what actually ends up happening? We're not dividing by 1,000 or 100 or 10. What are we dividing by here? We're dividing by 3. 27 divided by 3 is 9. 9 divided by 3 is
3.
Oh, I wonder then, what would be the next power here in the integer set?
Negative.
To the, don't leave 0 out. Come on, 0 gets so neglected. 3 to the 0 power, what do you suppose that is?
0.
0?
Anything times 0 is 0.
Okay, so it's 0. Because 3 divided by, isn't it, remember the pattern that's going on here? Divide by 3. 3 divided by 3 is 0?
3 divided by 3 is 1.
It's 1. It's not 0. Well then, let's keep going. We're going to move over here because I'm trying to run out of space. 3, what would be the next one? Going down?
Negative 1.
Negative 1. So what do you suppose that equals?
Negative 3.
Negative 3? Okay. So in other words, 1 divided by 3, because remember we're keeping the pattern going, divide by 3, divide by 3, divide by 3, divide by 3 is 1 divided by 3, negative 3, positive 3.
Oh.
1 divided by 3. I have $1. You know, I've just been giving away too much money lately. I'm down to $1. And I say to you, okay, 3 of you, fine. I don't need to eat lunch today. I'll just split it up between the 3 of you.
It'd be like
Are you each going to get $3?
No.
it'd be like 33 point something repeating. I know it's a decimal. Isn't it?
It'd be 1/3. Yeah, it'd be 0.3 repeating that decimal you're trying to describe. It would be 1/3, wouldn't it? Huh. Well, so if I have $1 and I'm going to divide it up amongst 3 of you, each of you are going to get 1/3 of my dollar, right? I can't really rip it in 3 pieces, but I could somehow find 33 1/3 cents for each of you. Okay. Well, now what would 3 to the negative 2 power be then?
2/3.
1 what? Aurora says 1/9. Cody says 2/3.
I agree with Aurora.
You agree with Aurora. That's some head shakers for 1/9.
Ooh. 1/6.
1/6.
Because 3 times negative 2 is, or 2 divided by, no. Well, if you have the first 1/3 is 3 times negative 4, 3 times negative 4, 3 divided by. So wouldn't it be 1/6 for the next one?
3 times 2 is 6. Seems likely. Why is it 1/9, do you think? Aurora?
Because we were dividing by 3.
Okay, we were dividing by 3. So she's saying if you take 1/3 of something and divide that now by 3, you're going to get 1/9. You think that's true? So now, basically, think of it, you know, like, even though we can't really have 1/3 cent, take that 33 1/3 cents that you got from me, and now you divide that up amongst 9 friends. How much are they going to get? Well, you got to take that
33
33 1/3 and divide it by
1/9 or 9.
3, and then you'd have to figure out what 1/9. You'd have to figure out what that is of $1, right? So let's see if 1/3. This is Aurora's thought process. She says, you know what? You got to take the previous one and you got to divide it by 3. Well, we're kind of having a little hard time processing it with money anymore. So now maybe we could do the rule that says if you can't really divide nicely, like can we take 1 divided by 3 and get a nice number? No. So then we can change this to a multiply by the reciprocal problem.
So
And
3/1.
this is 3/1. Its reciprocal then would be 1/3. And looky what happens. 1/3 times 1/3 is 1/9. So Aurora and other head shakers with her were correct. That's 1/9. Well, now we're finally getting to 3 to the negative 3 power, the original question. 3 to the negative 3 power. What would that be? 1/27, Michaela thinks. Okay, why would it be 1/27?
Grab grab 1/9 and you divide it by 3
When you divide it by 3,
times its reciprocal would be
change it to times it by its reciprocal,
1/9
and
times.
why, looky there, we would get 1/27, wouldn't we? So, I want you right now on your calculator to see what 1 divided by 27 is. This is that 0.003. Is 1 divided by 27, 0.003. Is that what it comes out to? Comes out to 0.037. Is that the same? No, that's not the same. So can we have that thought process that if it's to a negative power, we just move the decimal to the left that number of times? Can we have that thought process? No. Can we have that thought process that it's going to make it negative? The negative power is going to make it negative? Is anything becoming negative over here in our work? No. Nothing's becoming negative. Would you think it ever will get negative? What's it going to do?
It's
This denominator is gonna keep getting bigger,
And the numerator is gonna stay as one.
and the numerator is gonna stay as 1, which should do what then? Is,
Stay positive.
okay, 1/3, 1/9, did it get larger or smaller?
It got smaller.
That's smaller. 1/9, 1/27, did it get larger or smaller?
Smaller.
Smaller, so should the next one get larger or smaller?
Smaller.
Smaller, and
Smaller.
yeah, and here's what's gonna happen, is you're gonna keep getting so small that eventually you can't even write it hardly, because it's such a small number, but it's never gonna get to 0. It's never, it's still going to be a positive value. And that's important for us to know, okay? So let's start filling in some stuff here. Taking a non-zero number, in other words, 0 can't be the base. 0 cannot be the base. Taking a non-zero number to a negative power does not make the answer negative. It will always stay positive. Don't think that because there's a negative sign up in that power, and you know what, powers mean multiplication, so then you might start thinking, oh my goodness, that means I'm going to be multiplying some negatives, which means my answer has to turn out negative. No, that negative power means exactly what we just explored here. It means you just keep dividing by that base as the exponent gets smaller and smaller, so does the power that you're. So taking a non-zero number to the 0 power does not make the answer 0. Because remember what your first answer was for me when I said what's 3 to the 0 power? You said 0. Because what happens when you multiply by 0?
0.
You get 0. But we're not multiplying by 0. We're taking something to the 0 power. When we're taking something to the 0 power, do you think this would happen no matter what the base was? What if the base was 10?
10 to 0 is
10 to the 3rd power, 10 to the 2nd power, 10 to the 1st power, 10 to the 0 power. Every time we would not be dividing by 3, now we would be dividing by 10. Well, right here, when we got to 10 to the 1st power, what would 10 to the 1st power be? 10. And what's 10 divided by 10 for the 0 power? 1. Every time you divide something by itself, you're always going to get 1. But try this on your calculators. Try taking 0 to the 0 power. See what happens. Think it's going to be error? Why?
You can't take 0 times itself.
And divide by 0. You can take 0 times itself. Well, you sure can. But aren't we dividing here? When we're going down in powers, aren't we dividing? So we're kind of saying then that the previous power must have been whatever, and we're dividing by 0. Can we divide by 0? No. So this is why it says right here in both of these, we're talking about non-zero numbers, okay? 0 can't be the base. When 0 is not the base, then what can we count on? We can't count on this. The answer does not become negative because it's a negative power. The answer does not become 0 because it's a 0 power. Don't be misled and let that happen, and trust me, you will sometimes. Here's what we can count on when our base, x, is not 0. X to the 0 power will always, remember, when x does not equal 0, will always equal what?
1.
1. We don't even care what x is. In fact, let's try, let's try some of them. Let's take a positive number. Let's take 4 to the 0 power. On your calculator. 4 to the 0 power. Oh, that's a great place. Where's yours? Oh, not sure. Oh, and yours.
Sure.
And yours. Just, anybody see the word optional over here?
No.
Oh, okay. What was 4 to the 0 power? 1. Okay, what is 1 to the 0 power?
1.
1. What is negative 2 to the 0 power? Okay, try it on your calculator. Take negative 2 to the 0 power. Negative 1. Wait a minute. We said it doesn't matter what x equals, it just can't be 0. It should be positive 1.
That's only if your x. That's only if your exponent is negative. If your base is negative and your exponent is positive, you'll get a negative number.
Still
Aurora says 1. I like your calculator. Let me see yours. Michaela's does say -1. Oh no. Okay. What's the rule for the calculator? Or even when you're showing work, I'm taking a negative number to a power from a right. You have to put it in parentheses. So, trying with parentheses, Michaela, and see if we like your calculator a little better than that. Tell me what you get.
Oh, I got -1.
Okay, so did you
I
hear
can
what I'm
go
saying
bigger,
right
yeah.
now? Yeah, do you hear what I'm saying right now? What are we
Yeah,
gonna
sure.
do? What are we,
I'll
what
do
did I
it
just,
again,
what did I just say?
Yeah. Hey, you ask Michaela.
So I can check out CL. I don't
Right.
need to be here, my name is Michaela. What did you get?
I got 1.
This time you got 1?
Yeah.
But the other time you got -1?
I don't know.
But I wonder which one you can trust.
I don't know.
The power of the parentheses.
The power of the parentheses is right. What do we have to do when we're taking a negative number to a power? I don't care what the power is. You have to put it in parentheses. Because otherwise, here's what it's doing. It's taking just the 2 to the 0 power, and then it says, oh, by the way, take my opposite now. And the opposite one is -1. So we have to say, no, it's -2 that I want to take to the 0 power. So you have to use those parentheses, okay? It's not optional. Just like bringing your calculator to class is not optional, okay? So here's what we can count on when you're taking x, a non-zero base, to a negative power. Here's what we can count on. Oh, let's go over here and explore something. So 3 to the third power was 3 of these, so it's 27. But look at what happened when we got over here to negative territory.
It became
The denominator became the 3 to the first power. The denominator became 3 to the
second power.
second power. The denominator became 3 to the third power. Huh.
It's the opposite.
How do you think we could algebraically say what should happen? Cody?
It's a reverse. So if you have 3 to the third power equals 27, and you have 3 to the negative third power, it's just its reciprocal, 1/3, or 27 over 1, which would be positive 3 over 3, or 3 to the third power would be 7 over 1, and then negative, or 3 to the negative third is 1 over 7, or 27.
Okay, so how do we state something really simply algebraically that we could, a little rule we could do? Because I'm not sure most of us follow that because we're kind of hungry and our brains aren't following. So algebraically, you got a way we could do that because I think you know, you got it, Cody. You just like stated it in terms that the rest of these people are now in Spain instead of here with us in North Dakota. Okay, so how could we write that, I wonder? So in other words, here's what he was saying, I think. Here's what I think he was saying. He said when you take 3 to the third power, you get 27. And then he said the other one is its reciprocal. So he said if you have 3 to the negative 3 power, I mean, I'm just kind of shortening and tightening this up for you, Cody. It's the reciprocal of that, so it turns out to be 1 over 27. But in reality, 1 over 27 could be rewritten as 1 over 3 cubed, couldn't it? Oh. So how could we write that saying x is our base? If x is our base, we don't know what it is, it just can't be 0. If x is our base, and we're taking it to a negative power, how could we change it so we get rid of that negative power? Cody?
Or we get rid of the negative power,
Yeah, we don't want a negative power anymore.
multiply by another multiply the exponent by another negative power.
No, can't do that. A negative times a negative works in multiplying, but when you're doing exponents, that's like taking a power to a power then, and we're not taking a power to a power here. So, here's what it is, you guys. It's this. It's that simple. The exponent becomes positive, just like it did here, over here. It becomes positive, and it now is no longer the numerator, it's now the denominator. So, if x was 3, 3 to the negative 3 power would be 1 over x to the positive 3 power. Okay, and then, so notice what happened. It's kind of like, we could make that into a fraction, couldn't we? It's kind of like these two traded floors and the power became positive. What do you suppose happens when the power's downstairs? It's something, a base being taken to a negative power down in the denominator.
It's just gonna be x to the n power.
It's just going to be x to the n power. It's going to move upstairs, and the 1 would move downstairs. And we know that anything divided by 1 is itself, so it's really just x to the n power. So these are the things that are going to happen to you. You're going to have to be able to, they're not going to allow you, oh, I got to get plugged in. They're not going to allow you to leave negative powers in your expressions. They're going to say it's not simplified. Okay? So we can't leave those powers. I thought I was plugged in, but you got to be at both ends, not just one. Okay, so we're going to, we'll do a little bit of practice with it, but that's how we state it algebraically, the rules algebraically. You can count on, this is how you can simplify. Okay, but then I want to go over a couple of other things, and we kind of already just did this. Negative 2 to the 4th power, no parentheses, does not mean the same thing as negative 2 in parentheses to the 4th power. Here, when we have it written this way, only the 2 is being taken to the 4th power. So we have 2 times 2 times 2 times 2, and then we also have to take it times that negative sign out front, which is really just a negative 1. So what would that be? We don't need our calculators. What's 2 times 2? No, just 2 times 2, 4, and then times another 2.
16.
And then times another 2. 16. So this would be 16, and then we have to make it its opposite. Negative 16. And if you put it in your calculator, that's what should happen. You put it in just like that. Negative 2 raised to the 4th power, your calculator should say negative 16. But if you mean to take a negative 2 to the 4th power, this is how you would write it. Because here, now we're saying, oh, it's negative 2 that you want to raise to the 4th power. You want to take negative 2 times itself 4 times. What's a negative times a negative?
Positive.
Positive. Times another negative. Negative. Times another negative.
Positive.
Why, look at there. Is it negative 16? No, it's positive 16. 2 different things, 2 different answers. Okay? Now, you're going to think you're going to disprove me one day. You're going to come to me like, you know what, Mrs. Grant, I didn't use parentheses around my base, and I still got the right answer. And we're going to talk about that then. I'm going to say, well, why did that happen, I wonder? Okay, what was going on there? Okay, so I want you to evaluate right now then, without your calculators, what that expression would be. Go ahead and do it. Whatever you're going to do to make it happen without your calculator. And the answer is?
8.
Positive 8? Oh, because the negative times the negative is a positive? Is that why?
No.
Can you do this? Can you say a negative times a negative is a positive? Get rid of those guys right away.
Yeah, you can. You want to shortcut it.
If you want to shortcut it. Okay. So would that have worked up? Let's see. I gotta do it somewhere else. Let's see if it would work on this one then. If we did it with that negative 2 to the 4th power, we had a negative out front. Would it work with that? No? Yeah? So
No.
negative 2 to the 4th power. So can we take a negative times a negative, make it a positive, and then say 2 to the 4th power is 16? Would this equal 16? Well, we'll explore that in a little bit then. So over here you're saying, well, you know, in reality you can, because in the end you're supposed to get a positive 8. And a negative times a negative is a positive. Okay, but let's try. Is this what your paper looks like? Something like this? Negative 2 to the 3rd power means negative 2 times itself 3 times. But then there's that negative out front that's also a factor. Yeah? So this is a negative. And this is what? What does that become? Negative 2 times negative 2 times negative 2. That's negative 8. So this is really asking us what's the opposite of negative 8. Or it's now at this point, because we've gotten rid of the power, we could say a negative is a positive. Okay, if we use that same and said, I can shortcut this. Now that that worked, I can just shortcut it. I can say a negative is a positive. I don't have to worry about it. Okay, but let's do it the same way we just did that one. That's our negative factor. And then we have negative 2 times itself 4 times this time. Oh. So 1, 2, 3, 4 of them. What's a negative 2 times a negative 2? Times another negative 2. Negative 8 times negative 2. Positive 16. So there's our negative sign, and here's our 16. What's the opposite of 16? So it's not positive 16, it's negative 16. So can we take that shortcut all the time?
No.
No, we don't ever want to take it, because you know what? In reality, it's not going to. If it doesn't work all the time, you don't get to shortcut. Only shortcuts that work all the time. Clara?
For that negative, can you just put a -1?
You can make it a negative 1, absolutely. So right here, you're saying in this factor, can I just make it a 1 right here? Yep. You can do that. Okay, anybody else have any questions? This is all just, clarifying so that you don't think that there's some things you can get away with that you really can't. I just don't want you to, get in trouble. Okay, let's go to the back side. We're only going to do the check it out problems here, 2A through 2D, and tomorrow we'll move on from there, okay? An expression is not simplified. Would you underline, box, something? Not simplified. When you have negative or 0 exponents in it, it is not simplified. So if you come and you think your assignment's done and the directions were simplify the expressions and there's still a 0 exponent involved in there and or a negative exponent, it's not simplified. Kind of like if you start with 32 over 64 and you come to class with the answer 4 over 8, you're still not done with it. It could still be simplified more. So we're going to do, this is how we will show work not using calculators. 10 over negative 4, we're going to use that rule on the front that said if the exponent is negative, it can become positive where?
On the bottom.
On the bottom. So we could rewrite this as what? 1 over
Negative.
10 to the positive 4 power. We just got rid of our negative exponent that way. And here's one of the ways I'll know, and there's no guarantee because there's ways to set calculators, but one of the ways I'll know you're using your calculators, you don't show me this step first of all. And second of all, you give me your answer as a decimal. Because right now, in your calculators, those of you who have them, would you take 10 to the negative 4 power and tell us what it gives you? What is 10 to the negative 4 power? What does it say? 0.0001, right? What is that? What is 0.0001? Other than a fairly small number.
To the 10,000.
1
to the 10,000.
Yeah.
1 10 over 10,000.
1 10,000 is what that is. And so here's how we're going to do it. We're going to say 1 is going to stay 1, but 10 to the 4th power is what? What is 10 to the 4th power? 10 times 10 times 10 times 10.
He's right.
10,000, yeah. Well, he has his hands in front of his mouth, like I'm supposed to understand what he's saying. 1 over 10,000. That's the same as 0.0001, what your calculator gave you, 1/10,000, but this is how we're gonna write it. Okay, showing that we know how to do this without the calculator. Okay? So what do you think we could do with that next one? How could we start that one?
Negative.
So
2.
here's our base, -2, being taken to a negative power. Focus on that negative power right now. What could we do to get rid of that negative power?
1 over.
Cody?
You can do 1 over -2 parentheses to the 4th power.
Okay, exactly. That's exactly what we could do first. And then we would say, oh, that equals 1 over whatever -2 to the 4th power is. Is it -16?
Positive 16.
Positive 16. Positive 16, isn't it? A negative times a negative is a positive, then times another negative is a negative, and then times that negative again is a positive. So it ends up positive 16, so 1/16 is our answer. The calculator would give this as a decimal, and this decimal, you would look at it and you'd be like, I have no idea if that's 1/16 or not. Okay? Okay, how about the next one? How would we start that one?
1 over -2.
So 1 over -2. Are the parentheses important?
Yes.
Whether it's being taken to a positive power, a 0 power, or a negative power,
Yes. It is
it's important. They're important, aren't they? Absolutely they are. It does not matter what the power it's being taken to is, no matter what the integer power is, we have to use this parentheses. And now it's a positive 5 power. That's how we got rid of the negative, is by moving it down. We're making it, showing that we kept dividing by 2 5 times. That's what's happening. And what do we end up with? 1 over, well, a negative times a negative,
It's positive.
times another negative,
Negative.
times another negative,
Negative.
times a negative,
Negative.
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 Hey, do you guys, there is a shortcut for multiplying with negatives. If there's an even number of times that you have a negative and you're multiplying, what's it going to always turn out to be? Positive. When there's an odd number of negatives you're multiplying, it will always turn out
Negative.
negative, yeah. So this is an odd number of negatives, so it's going to turn out negative, and 2 to the 5th power would be 16 times 2.
32.
32. Now, we're not going to leave our answer like that, because that's how we would see it in an answer bank. When we have negatives within a fraction, we deal with them. We say if there's only one negative, it can come out front. If we ended up with a negative both up and down, we would say they cancel each other out. But we only have one negative, so we bring it out front, and we say our answer is negative 1/32. So in the end, these are our final answers for these problems. And this is showing not using a calculator, basically. Okay? And how about our last one here?
1 over -2 to the 5th power.
Is it -2 that's being raised to the -5 power? What's being raised to the -5 power in this problem?
2
Just 2 is, isn't it? So here's what we're going to do. We're going to do like Clarence said, can we make that negative sign a -1? So let's first do that. Let's say this really is a factor of -1. And then we have 2 being raised to the -5 power. That's really what's going on, because that negative sign was not in a parenthesis with that 2. So the base is 2, not -2. So now we can rewrite this as -1 is going to stay -1. And it's going to be multiplied times our 2 to the -5 power, rewriting it without its negative power.
1
What
over
is
2
that?
to the 5th.
1 over
2 over 2 to the 5th power.
2 to the 5th power. Okay, well now, that's going to become, let's make that -1 into a fraction also, since this second one's a fraction. We know how to multiply fractions. And what's 1 over 2 to the 5th? 1 over 32, or what did I hear? Okay, so now I was just renaming this. So this right here got renamed as 1 over 32, right? Now, we have a negative 1 upstairs times a positive 1, that is negative 1. I'm running out of room. Negative 1. And downstairs we have 1 times 32, that is
32.
32. Do we have can we cancel any negatives? No, so we're going to bring it out front and say our answer is negative 1 over 32. Just so happens you got the same answer as the one before, and I wonder why that happens. Okay, so that's all we get to do today.